Hello viewers, welcome to add-on. In this question we are asked to explain the amplitude modulation with the help of mathematical expressions and appropriate diagrams. Okay, so let us start. So by modulation we know we use the modulation technique to transmit a signal from a transmitter to receiver. So suppose this is a transmitter and this is a receiver. So if we want to transmit a signal from this point to this point, we use the technique of modulation. Why do we use the technique of modulation? Suppose this is a weak signal or a low frequency signal. So a problem may arise when a weak signal is transmitted over a long distance from a transmitter to receiver. There may arise some kind of distortion or some kind of noise, some or any kind of uncertainties in this particular signal. So what happens when we are receiving the signal? The data we are receiving at the receiver is completely different from the data we are transmitting at the transmitter. So to solve this problem, we use a high frequency signal. Okay, the high frequency signal to modulate this low frequency signal to make sure that the data is not diminished or doesn't get any kind of uncertainties at any point of transmission. Okay, so this is our main aim of modulation. Now modulation is of three types, because suppose this is a high frequency signal and this signal needs to get modulated by this signal. Okay, now this signal has three entities. One is the amplitude. Okay, one is the amplitude, one is the frequency, and one is the phase. Okay, so the three entities are amplitude, frequency, and phase. So in our question we are asked about amplitude modulation. So in amplitude modulation, what happens? The amplitude of the carrier signal changes according to the amplitude of our message signal. Okay, so here we can see in this particular diagram, right? In this particular diagram, this is our message signal. Okay, this is our message signal, or for our simplicity purpose, let us assume that the message signal is like this. Okay, so the message signal is a low frequency signal and the carrier signal is a high frequency signal, because if we are considering this time period, which is t, okay, for this negative half cycle, okay, this is t, and for this carrier signal, this is the negative half cycle, this is also t. Okay, so as I have said, the message signal is a low frequency signal and the carrier signal is a high frequency signal. Now f is equal to 1 by t, frequency is equal to 1 by time period. So if frequency is high, time period will be less, and if frequency is less, time period will be high. Okay, so as we can see here, the time period is high, so the frequency will be less, so this is a low frequency signal. Okay, and here the time period we can see is less, so if the time period is less, frequency will be high, so this is a high frequency signal, right? So we need to modulate the amplitude of this carrier signal by this message signal, right? So what happens? Suppose this is a message signal, the amplitude is continuously increasing, and at this point we are getting a peak value. Okay, and after this point the amplitude is decreasing, and at this point the amplitude reaches its minimum value. This is the negative peak. Okay, the maximum value is the positive peak and the minimum value is the negative peak. Suppose this positive peak has a value of plus 5 volt and this negative peak has a value of minus 5 volt. Okay, so the amplitude of the carrier signal will be maximum at this point and it will be minimum at this particular point. Okay, so at first the amplitude of the carrier signal will start from 0, then it will slowly increase, and at this point it will be maximum, and then after reaching this point it will again decrease, and it will decrease and reaches its lowest value at this particular point, and after that point it will gradually increase. Okay, so as we can see, the carrier signal amplitude started from 0 here, it is gradually increasing, and at this point it reaches the maximum value. Okay, and after that it is again decreasing, and at this point it reaches the minimum value. Okay, and after that it will increase again. Okay, so this is how the amplitude of the carrier signal gets modulated. Okay, now in order to obtain the mathematical expression, let us say the message signal m of t is equal to a of m cos of omega mt, or we can say instead of cos, let us say a of m sine of omega mt. What is a of m? It is the amplitude of the message signal. Okay, a of m is the amplitude of the message signal, and omega m is the angular frequency of the message signal. Okay, so this is, so suppose this is a of m, and suppose omega m, it is the angular frequency of the message signal. And now for carrier signal, let us assume it is a of c sine of omega c of t. A of c is the amplitude of the carrier signal, and omega c is the angular frequency of it. So a of c is the amplitude of the carrier signal, and omega c is the angular frequency of it. Okay, so what do we do? Let us say the output signal is y of t, so it will be equal to y of t. Y of t is equal to a of c plus a of m. Okay, or we can say a of c plus a of m sine of omega mt into sine of omega ct. Okay, this is our output expression, because the amplitude will get modulated, this amplitude, this will get modulated according to this message signal. Okay, so we are just adding it, a of c plus a of f sine of omega mt into sine of omega ct. Now if we take a of c common from it, we will get 1 plus am by ac. Okay, 1 plus am by ac sine of omega mt into sine of omega ct. Okay, so this a of m by ac, this term is replaced by the term mu. What is mu? Mu is the modulation index, which signifies how much modulation is done. Okay, so we can represent it as a of c plus 1 plus mu sine of omega mt into sine of omega ct. Okay, so if we find out the products, we will get ac of sine of omega ct plus mu of ac sine of omega mt into sine of omega ct. Okay, and if we expand this term, sine of omega mt and sine of omega ct, we know sine a sine b is equal to cos a plus b plus cos of a minus b. Okay, so we will get ac sine of omega ct plus mu ac by 2, we know, because sine a sine b is equal to 1 by 2. Okay, basically the formula was 2 of sine a sine b is equal to cos a plus b plus cos of a minus b. So here sin a sin b term is present, so sin a sin b is equal to, this 2 will come here, 1 by 2 cos of a plus b plus cos of a minus b. So we will get mu ac by 2 cos of omega c minus omega m into t plus cos of omega c plus omega m into t. So this is our output am wave, and this signal is the carrier signal which we are getting. And this is our lower sideband, and this is our upper sideband. Okay, this is the lower sideband LSB, this is our upper sideband USB, and there are total 3 frequency component. This is omega c minus omega m, and omega c plus omega m. Okay, so if we draw the spectrum of it, we will get, this is suppose f of c, which is the carrier frequency, this is fc plus fm, and this is fc minus fm. So this particular portion, this is the upper sideband, and this particular portion, this is the lower sideband. Okay, so this is the lower sideband, this is the upper sideband, and mu, this is the modulation index, which is equal to am by ac. Okay, and this mu ac by 2, it is the sideband amplitude. For the lower sideband, the amplitude is mu ac by 2, and for the upper sideband as well, the amplitude is mu ac by 2 as well. Okay, so let us understand one thing. First, let us clear some space here. Okay, so we know mu is equal to modulation index is equal to am by ac. Okay, so there are 3 conditions of modulation. One is critical modulation, one is over modulation, one is under modulation. Under modulation occurs when mu is less than 1, over modulation occurs when mu is greater than 1, and critical modulation occurs when mu is equal to 1. Okay. Now in amplitude modulation, our ideal scenario will be mu is less than equal to 1. Okay. So it can be either under modulation or it can be either critical modulation. But it uh, can't be over modulation, because when mu is greater than 1, distortion occurs. Distortion occurs. So we can't make mu greater than 1. Okay. And now one thing we need to know, this is the AM wave, right? This is the AM wave which we are getting after modulation. So what is the amplitude of this AM wave? Okay, we need to know the amplitude. So initially the carrier amplitude was AC. Okay, but here what we have done, uh, here we have done AC plus AM sine of omega mt, right? So what we have done is that we have added the amplitude of the carrier signal with the whole sinusoidal wave, which is this signal, right? So as we can see, this particular signal, this which we am denoting by the black line, this particular signal is specifically denoting what? It is denoting this message signal, okay. So what happens when we do the modulation for this same wave? The maximum amplitude which we are getting is equal to what? The maximum amplitude which we are getting is equal to AM plus AC, or AC plus AM, and the minimum amplitude which we are getting are AC minus of AM. This is the minimum amplitude and this is the maximum amplitude. Why? Because as we can see in this particular waveform, right? In this particular waveform, this level, this dotted line which is denoting here, right? This dotted line represent what? This dotted line represent the amplitude level of the carrier signal, which is AC. And now whenever doing the modulation, this level get adjusted according to the amplitude of the message signal. Now when the amplitude is larger than AC, okay, like when AM is added to it, we will be getting this particular point. So this is AC, and after adding AM we are getting this point. So this point will be AC plus AM, okay. And now this point, for this particular point, this point is AC, and from AC up to this point we need to subtract something from it, and this subtraction will be performed by AM. So this is AC minus AM, okay, because as the amplitude, because AM is the amplitude of the message signal, so as the amplitude increases for the message signal, the carrier signal will get adjusted, and similarly as the amplitude decreases, the carrier signal will also get adjusted, okay. So I think we have understand the modulation technique in detail in this scenario. So that's it for amplitude modulation. Thank you.